Good afternoon. I am Dr. Rene Luis Gutierrez, and I will be discussing the topic of Introduction to Medical 3D Stereolithography in CMFS. Advances in imaging techniques with digital 3D and 4D rendering and advances in 3D printing have allowed healthcare professionals the ability to view and document hard and soft tissues in such a manner that meaningful, accurate measurements can be used for fabrication of medical models. Here are the objectives of my introductory lecture in medical additive printing in CMFS. So what is medical additive printing? 3D stereolithography, or simply 3D printing, is an additive technique. It is a process through which a three-dimensional solid object, virtually of any shape, is generated starting from a digital model. This technology has multiple applications and is the fastest growing innovation in the medical field. This slide shows a summary of characteristics of 3D printing technologies commonly encountered in medicine. Today we will discuss about the three primary steps in the workflow. Image acquisition is the first step in our workflow. These are the recommended protocols for 3D printing. The next step in our workflow is digital surgical simulation. In this step, several imaging softwares are available so that you can do segmentation, mirroring, and movement of bones. Several input devices may be used in virtual surgical planning for your segmentation, mirroring, or movement. You can use your keyboard, mouse, trackpad, a pen, or even a haptical input device such as this. Once computed tomographic data are acquired in axial, coronal, and sagittal cuts, we can now proceed with virtual segmentation. This is a process of dividing our images into subregions and analyzing each data. This is a common panel that you can see in several digital imaging segmentation software. As seen here are the pixels that we will use later in our segmentation. Image noise are always encountered when metallic objects are present. They serve as artifacts and is a big hindrance encountered in digital processing. A way of eliminating these artifacts is by using the region growing technique in segmentation. This is a technique of identifying similar and connected pixels. Another technique in segmentation process is split masking. So in split masking, we just choose several areas of our image, and then the computer software will analyze it and split it into segments. Sometimes you may encounter fragment overlap. This is due to the interconnected pixels. Again, this is the image noise or artifacts that we have mentioned earlier. One technique to eliminate this is by using the multiple slice edit. Other techniques for segmentation of your virtual images includes Boolean operations tool and the wrap tool. Once you finish the segmentation of your 3D images, you can then export this using the STL file for printer recognition. Always remember to do a final check on your STL images before exporting and printing these models. Printing the planning model. We will now discuss the steps in preparing a stereolithographic model. First, you need to calibrate your 3D printer. You need to load the base and support materials in your material loading tray. Check the print material model platform and always empty your waste material bin. Sometimes your printer will not proceed to print your model because it detects that the model is outside the tray area, and usually these are due to artifacts. When everything else is ready, you may now proceed to your printing. In this video, you can see the printing process whereby the liquid resin is applied on the top of our model as the base is going down. You can also see a laser light curing the liquid resin along the way. Once finished, your build plate will go up and you now have your 3D model. The printed model usually has support materials around it, and you need to clean it by using a jet water technique and manually remove these support materials. Here you can see the software generated image and the stereolithographic model that we have just printed. You can either print it in glossy, semi-gloss, or matte. So, these are the advantages of 3D printing: injury prevention, model cast fabrication, accurate surgical approach, good cosmetic results, and it enhances training and documentation. However, the disadvantages are need to improve user-friendly applications and softwares, expensive hardware and software products, availability of printer spare parts and consumables. These are some representative cases that we have done. Continual advances in medical imaging, reconstruction software, and 3D printing continue to aid and advance in the field of craniomaxillofacial surgery. Technological advances, including more user-friendly software, will enhance utilization. As these technologies become increasingly available and affordable, adoption may eventually become a routine. This is the end of my lecture. Thank you very much.